share my screen. Okay, hope you can see my screen now. Right, so what's the plan? We're going to talk about monitoring application performance using Azure Application Insights. I'm going to start off with a bit of a description in what Application Insights is, how we can use it, what it tracks, what it monitors, and then we'll move on to a more interesting bit, that is sort of a case study, an application that uses a few other different Azure components and relies heavily on Application Insights to sort of give us some good information about how the application behaves out there in the world and in the cloud, and a few of the decisions that I've taken based on the feedback from Application Insights. So I hope you find it interesting. Right, so let's start with what is Application Insights. Is essentially it is a feature of Azure Monitor, and it's an extensible application performance management service for developers and DevOps professionals. We use it to monitor our live applications, and it will automatically detect performance anomalies and includes powerful analytics tools to help you diagnose issues and to understand what users actually do with your application. And it's also designed to to help you continuously improve performance and usability. Now, I've mentioned it's part of Azure Monitor, and that's Azure's platform for clearly monitoring your application out there. And it's not a Azure Monitor. It's not just for your web apps. So you can have the various sources in here, being the application, the operating system, your Azure resource subscriptions and tenants, and you can have custom sources as well. And as you can see, Insights is just one of the components in that. This diagram shows a high-level overview of Azure Monitor, and in the center of the diagram, are the data stores for metrics and logs, which are the two fundamental types of data used by Azure Monitor. On the left are the sources that populate those data stores, and on the right are different functions that Azure Monitor performs with this collected data, such as analysis, alerting, and streaming to our external system. All data collected fits into one of the two categories, metrics and logs. Metrics are numerical values that describe some aspect of the system at a particular point of time, and they are lightweight and capable of supporting near lifetime scenarios. Logs, on the other hand, contain different kinds of data organized into records with different set of properties for each type. Telemetry, such as events and traces, are stored as logs in addition to performance data, so that it can all be combined for analysis. What we can use Application Insight for, so we can track request rates, response times, and failure rates. See which pages performs best. We can use it for dependency rates, response times, and failure rates. I think Craig has posted recently something in one of the Slack channels where you've seen a few dependency rates as well, as an example. So you can, and I will show you a few examples of that as well. We can track exceptions, analyze the aggregated statistic, or pick a specific instance and draw into the stack trace and the related requests. Both server and browser exceptions are reported. We can also show page views and load performance reported by your users' browsers. You can track AJAX calls from web pages. Again, you get rates, response times, and failure rates on those. User and session counts. as well as performance counters from your Windows or Linux server machines, host diagnostics like Docker on Azure or Azure, for example, trace logs, and obviously custom events and metrics. So there's like a lot of metrics, a lot of key performance indicators that we can track using Azure Application Insights. On top of that, Azure Application Insights provide for multiple platform support. So we have a lot of supported languages in here. We also have, what they offer is instrumentation for already deployed applications. Now the caveat here is it has to be like, for example, a VM. It needs to be deployed in Azure, so Azure VM. So there's like an extension you can install for the VM, and it would start collecting analytics instantly for your virtual machine, or VM scale sets for that matter. Azure App Service. So the app that I would show you, it's built around Azure App Service, just because of ease of management, etc. But that allows us to install the Application Insights extension as well. What we also have is a lot of SDKs. So pretty much most of every platform that's commonly used out there has its SDKs, and it's really easy to get started. And obviously they provide Application Insights, provide the support for various logging frameworks, like for example iLogger that we're using extensively across our applications, Log4net, etc. So basically what you can do is your logs can go directly into Application Insights as part of this. How do we get started with Application Insights? It's quite easy. So there's like what you can do is the new apps have this connected service item in the Solution Explorer. So if you double click on it, you'll get this connected service experience that's relatively new to Visual Studio 2019. And from there, you can not just integrate with Application Insight, but you can also do similar integration with storage accounts and key vaults as well. And once you select it, I'll show a quick demo after. Once you select it, it's just a matter of picking the subscription, the resource group, and the resource name, or creating one if you haven't got one. And it would install the SDKs, it would add the Application Insights telemetry key, and your app is ready to collect information. Once that's in place, we can view our telemetry in numerous ways. So you have the application map that, as you can see, shows various dependency times, error rates, etc. You have the application dashboard in Azure Application Insights. I'll show you a few examples of that. And yeah, basically it comes with pre-built dashboards that would give you an overview of your app's performance. And you can also build and save your own dashboards by querying the raw data using something called custom query language and rendering the results in a chart. It's not too difficult to get up to speed with custom query language. Fortunately, Microsoft has created quite a few commonly used queries to start with. So I'm going to show you a few examples of those as well. You can also view your telemetry in Visual Studio once you have the Application Insights. And one of my most favorite sort of feature of the Application Insights is the live metric stream. So what you can see is I'm gonna show you actual live metric stream out of the sample app that I've got. It's quite interesting to see what exactly happens with the application and how it performs at any given point in time. I want to also mention pricing consideration. Now, with application insights, you're charged for data ingestion and data retention. So basically, you have the option to reserve a capacity at a slightly reduced price. And obviously, you can always do enterprise agreement with Microsoft, and as with any cloud provider out there. But if you choose the pay-as-you-go, you get 5 gigabytes free per billing account month, and then it's just over £2 per gigabyte per month. And then you've got the data retention, 90 days by default, and then you've got 0.097 per gigabyte per month as well. So there's a few ways to reduce the cost that I'll sort of demonstrate as part of the overall functionality of application insights. There's like, you can reduce the sampling rate, and you can reduce the data retention as well, because you can sort of start exporting your data into a storage account where your costs are a bit lower compared to what you have for application insights. Right, so without further ado, let's do some demos. So I'm just going to quickly demonstrate you how you can do the connected services experience. So you simply click on the connected service, select application insights, and then pick the account, the tenant, the subscription, and the resource. You can create your own, and once your new one, and once that's done, you're good to go. Or you can also do add application insights. It's already added, so because I've already added it, there's an option to add application insights telemetry, so there will be additional menu item in here. Before we dive into the application, I want to sort of show you this diagram that would sort of demonstrate the infrastructure in place. So basically, that's built around microservices. So we have three web apps or app service apps that are running on a single app service plan. So those three are part of single app service plan. So we have probably, before I even dive into that, it's all built around a data from the UK police. So essentially, they would give you crimes at location. And essentially, this is basically the request for a given location. And basically, this application takes advantage of that. So there's a client that is built with Angular, and then there's two .NET Core API apps. The Crimes API, that's used to read the data from Azure Azure Table Storage, and there's the Post Codes API that uses a SQL database to fetch latitude and longitude information for various postcodes. Further to this, there's Azure Function. That function uses a very popular serverless consumption plan in Azure that essentially gives you a free CPU minutes every month. And essentially, once you spend more than what they give you for free, they start charging you then. So basically, it doesn't cost you anything, basically, and it does the heavy lifting. So basically, the idea of the application is a user would enter their district and then select their district in a month. And then what's going to happen is the client would post to the postcode API and say, okay, this is the district, give me all the postcodes within that district. And then it's going to enqueue. So this is where the service bus comes in. So it's going to enqueue, so let's say a postcode district would have 1,000 postcodes in. So for each postcode, it would enqueue a message in the postcodes queue. And basically, once it's all pushed into the postcodes queue, it's going to signal that it's good to go. And that's going to trigger the function. And the function itself, for every given, so essentially it's quite nicely decoupled. The majority of the functionality is nicely decoupled from the UI from those from those APIs into a function, and that function does the heavy lifting. So for every postcode is going to do, let's say, all of those 1,000 postcodes, it would do police API call from using this format in here, and basically it's going to do that, and once it gets the information, it's going to store the data into the table storage, which is for me is extremely cheap way of storing data. I'm going to show you some cost information for the entire resource group that's hosting this. Then it's table storage is really efficient. Probably not ultimately performant, but I would imagine Cosmos DB would be a lot performant than that. But back to our application. So application insights. So at every single stage of this, I'm using application insights to ensure that I'm monitoring the performance and to ensure that my app behaves as expected, etc. So they would give us visibility of what's happening at the moment. And some of my logs, I've added extra sort of verbose warning statements just to sort of give us more detailed picture of what's actually happening there. So onto the app itself, it's nothing much, but basically what you can do is that's the current data by group, by districts and dates. And what you can do is you can do this. Let's try something for April. And basically what it does is talks to the postcodes API. The postcodes API gives all of the postcodes to it, enqueues the message, and from then onwards, the service would start polling the police API endpoint.
That data is wrong. There's no way there's so little crime in Moseley.
That's just for April. So if we return now to application insights, so this is the resource group. So this is the app service plan that hosts the 3 API apps. So we've got, this is the app service plan, and we have the postcodes API, the crimes API, and the crime reporter, which is the client API app. So, and the function itself is the crime reporter serverless is the function that does all the work. So let's have a look what's happening currently. So I've enqueued that, and I'm going to show you one of my favorite features is the live metrics. So basically, I hope that the app the function would have started by that point. Yeah. So what you see here is every single message. So we've got some trace outputs here. So you see what's happening. So you can see in general, it takes around a second here for each. So let's say there's 1,000 postcodes in here. There will be 1,000 messages in the postcodes queue, and the function would pick 4 at a time, and it would try and fetch the data. So as you can see, this is all looking good. No exceptions so far. And this is, yeah, you can see a lot of verbose output to say, oh, there's mostly no crimes. That's good. That's good for, yeah, there's some now. But yeah, you can see the average duration of your requests. So what I'm going to do at the same time is I'm going to enqueue another one for the same district, but I want to do it for May. There's a bit of a delay with the latest data, and let's keep looking at this. I think soon enough there will be a few things happening that sort of that are kind of out of the expected. So far, everything is looking good. Okay, there's something here. There's a dependency 409. But this is the one that I'm a bit more interested in. There's 429. What happens is, basically, I think that's what we're seeing here is like with every good API, they're throttling me. So I'm asking for I'm making too many requests. As you can see, the duration of the request has increased as well. So basically, they're throttling my client. And basically, the application insights gives me that real-time information. So I know now they're throttling me. So what I've introduced as part of this is I've got the retries queue. So basically, as soon as I get 429, I'm shoving I'm pushing the failed messages into a separate queue. And once that happens, basically that second queue would retry the messages one at a time. I've mentioned earlier that this one does them 4 at a time, so it's quite a performant, that queue. But then my retries queue is a slower one, so it will allow me to definitely get those back, even though I got those failures to begin with. And this is just one example where this has given me that insight. And obviously, if I've read the documentation properly, I would have gotten to the same conclusion as well. But it's nice to see stuff like that happening, and you can sort of respond to that. That's live metrics. Let's have a look at the application map. You've seen, I think Craig shared similar diagrams, but basically what you see here is this kind of maps to the infrastructure that I've shown you here. Is just another view of your data. So you have the function app, the serverless app, that talks to a service bus queue, and then once it enqueues the message, and this is, you can see the average, you can see the average, how long it takes for a single API call so that's the dependency. And then once you have the data, then it goes to Azure table storage. And as you can see, the inserts are quite performant as well. Further to this, we have the raw logs. So this is where the custom query language comes into play. So this is just, if I just go for the requests instead, you can see the raw data that's been, the logs that are being collected from application insights. And this is, the rest of it is part of the custom query language syntax. Another interesting one, let's have a look at so this is the serverless app, but let's have a look at the Crimes API. That's the one of the web apps. And what I can see a constant requests in here, which seems a bit odd, like at regular intervals. And because I have application insights for that, so let's have a look what's happening. And then this comes in. The first time I saw this is like, what's wrong? Is it what's pinging my app? Then I realized basically what happens is in the configuration of your web app, what you can do in the general settings. When you turn always on, it pings it makes those get requests to your API. So we're all good. There's no, probably I need to get an endpoint. That could be like a health or monitor probe endpoint type of that I haven't implemented. But yeah, you can drill down and get into the nitty-gritty details of what's happening. So it just tells you, oh, it's not found. Yeah, and another interesting one that I've seen is, so we have this application dashboard that I mentioned from our presentation. So this is a nice overview of your entire web app that gives you the picture of what's happening. Now, I found this really interesting is, so you can see the various operations in here. So this is the get here is the ping. However, I want to have a look at this. This is quite slow. That's like 2 seconds. So let's have a look. There's 21 samples of that. So I can drill into it. So let's have a look at the first one. Basically what this is when you go in here and you pick district, it's going to do fetch. It's going to fetch the, just going to quickly show you the raw data. So this is what the raw data look like in the table storage. So there's some, it's partitioned by the district, and there's a various crime data in here, basically. So you know where it happened, the category, if there are any outcomes of that, etc. So basically what happens is, this is the get, and what happens is, I'm using, on the SDKs, because I'm using Azure Table Storage SDK, I'm using something called execute query segmented async. So each one of those is the individual. If you look at the next row key, so this is how execute query segmented async is performing. So it fetches the data from this particular partition key on segments, and they're quite performant. But in overall, because there's a lot of data, it's or probably it's not. If it's not super performant. That's why you get those 2 seconds. So when you do change this, that's the delay. That's the majority of the delay that's happening, because it tries to query the table storage, and so you can, what you can see is you can drill down to any of those examples and see what's taking too long. And as you can see the request URL, and then possibly you can make some decisions, or possibly performance considerations, and just essentially all of this is really useful information to get started on getting the insight for your application. And again, you have access to raw data. So what you've seen here is just charts that are based off. So this is the application map from the API app, for example. Client talks to the crimes API, and then that fetches the data from the storage table, and that's the postcodes API on the other end. And all of the data is available in logs. Now, I mentioned costs. Basically, this is my estimated cost based on the current usage. What you can do is you can reduce the data sampling. So if you don't want to sample all the data, you can do a lower percentage, so your data ingestion is lower. You can set a daily caps as well. Again, just so you don't want to be, if you want to set some limits, the data retention, again, configurable. And what you can do is set up continuous export to a storage account where the cost will be significantly cheaper. But yeah, I think that's sort of that's an overview of the functionality. The only thing I don't like with this is, let's say you have multiple applications. So currently it's not supported. It's in preview. But basically, if I switch to this resource group, I've got 2 virtual machines that are part of this log analytics workspace. So I can do my queries for all the resources, all the compute resources. So if I do that, it's gonna come back with the details for both virtual machines. I can't do that with Azure App Services as of yet. There's a feature in preview that would allow us to do that. So you can essentially, I think the goal is to be able to see performance across multiple applications, because it's great for single applications, but yeah, ideally you want to be able to do that for multiple applications. So like this dashboard, but for multiple applications. And I've mentioned costs, and you can see how much the table storage costs for the past 30 days. And the table itself has just over 100,000 entities in here. And yeah, as you can see, it's not that expensive. There's a bit of a cost to analytics. As you can see, those various application insights components here, they're costly. But as I said, you can do various things to reduce the verbosity of the output, or the sampling rate for that. So there's a lot of control there, and ultimately it's up to us to sort of control and always sort of develop with the cost in mind for those cloud solutions. And I couldn't cover everything, but there's like a lot of aspects involved to this. Like you can see the user flows, the page views, etc. That's built in. There's a lot of that as well. But yeah, that's just a brief overview of what application insights can do for you. If you have any questions, I'll be more than happy to answer to the best of my abilities.